Hi, hello everyone, and welcome to this video. So basically, last time we left off with our pedals and our scene, but this time we want to shade it actually. And for shading, we're going to use PONG shading, except that we're not going to do specular this time. So the specular lighting model has ambient light, which is just kind of a constant, and ambient light is just a light that surrounds uh, your environments all around, basically the world. So it's a bit strange to describe, but basically the light as it hits the surface bounces around. So all of that light contributed is kind of an ambient light, and since that is kind of too hard to model, right? You would have to model every ray and stuff, so we don't do that. We just have a constant, so that's going to be our ambient light, and then we're also going to do diffuse light. That's quite easy as well. And then specular, I was thinking of doing it, but since it won't look that good for this game, I think we're going to skip it and do the third shading instead next time or time after next time, because we're going to do point lights next time. So this time we're just going to do ambient and then directional diffuse light. So that's for this video, what we're going to do. So we can get started. And the first type of light is going to be ambient light, and the ambient light, we can just model it first. So I'm going to create here a new folder. I'm going to call it lights. And then here, I can just create an ambient light. All right, and then let's get started with it. So I'm just going to zoom in a bit so it's easier for you to see. So we're just going to say ambient light. And here we're going to have color. I don't need this. So the color, we already had some basically class for color, and then we have intensity. This is fine as well, but we're also going to have to need to have that buffer. In our case, we created, if you remember, this uniform object, which was basically holding buffer. So we're going to need that. We're also going to need a device to create that buffer. We can create a buffer, and the size of buffer is just going to be 4. Why 4? Because we're not going to use this alpha value here. So we're going to use these 3 values, RG and B of a color, and then intensity as well. And I'm just going to have one small update method, and then we can say this buffer update, and we could also pre-multiply it here, but actually we're going to do it in shader instead. So we're just going to paste these values, and here we can say this intensity for the last value here. So we're just passing red, green, blue, and then intensity shader. So now in our shaders, we're actually going to create a new shader, and it's going to be material shader, WGSL. So it's going to be similar to unlit, except that we're going to have lights here. So in our shader, right now what we want to do is actually create a struct for that ambient light, and here we can just change this to material vertex shader and material fragment shader. And here I'm just going to say var color. So that's going to be our material color, and then right somewhere over here we can create that ambient light, and it's going to be struct. So I already mentioned, and this is good suggestion here. So it's going to have color, which is vector 3, and then intensity, which is just a float. All right, we have an ambient light now, and so the WebGPU has kind of limitation on the number of groups, and we can see that limitation here. So you could either query for it via parameters, or we can just check the limitation. So here under, I think it's under adapters or devices, so we can find this max bind groups. So what that max bind groups means is that we can have 4 of these groups. So because we're going to need a group for light, I'm going to move this diffuse color to group 2, and then the binding is going to be 2. And here we can now do ambient light. So it's group 3 binding 0, our ambient light. We have color here, so we can say var color amount, amount, and that's ambient light color times density. So I'm just going to say ambient, because we're going to need this for directional as well. And finally we can just return color XYZ, or even better RGB. The context is important. It's kind of same, they're just a mask, right? But then we just multiply by color amount and return 1. So that's it for this part. So we did shader. Now we have to create a pipeline, and I'm just going to call it render pipeline. This, I'm going to copy unlit render pipeline, move it here, and here we have to do some refactoring. So first of all, this texture bind group is now going to be called material bind group. So let's just rename it. Material bind group, and then layout. Because we're also going to put this color, which I mentioned in shader here as well. So this is diffuse texture bind group. So this is material bind group. Material bind group. And we have this diffuse color bind group. So we can rename this to lights bind group. So let's see what we're going to need here. So this, we had this method, create texture bind group. So now let's create and the binding here, right? We did this in shader. So the resource is going to be not texture tiling buffer, it's actually diffuse color buffer. And I think this should be set like this, probably. Buffer. Exactly. All right, that's one change. So if you get stuck, you can just check GitHub code. Everything is going to be there as well. So all right. So this light bind group is going to take, we need to pass that ambient light that we have created. So let's just do it in a new line so that it's easier to see. Ambient light. Okay. Let's see further. So we had that ambient light, and this light bind group is going to take ambient light buffer, and then because this buffer was wrapper, we have to do buffer one more time. And I think we're almost done here. I just have to check those layouts. So diffuse color group layout doesn't exist anymore. It's actually moved to material. So let's do this, move it here. So this is binding 2. And this is now going to be called lights group layout. And this is quite alright. So light groups layouts is group 3, material is group 2. That's quite alright. So further, we actually need to make use of this render pipeline, and I forgot 2 things. First of all, this should be now called render pipeline, and then the shader name somewhere. It's probably a good idea to, yeah, here. It's not unlit material vertex shader, it's actually material. Same is true for fragment shader. And yeah, the label, I'm just going to call it render pipeline. If you need to do debugging, it's going to be way easier that way. And that's it, I believe. Light bind group, material bind group, this remains the same. Cool. So let's go to our pedal. We can focus on ball later. Let's just do pedal for now. So here we can pass that ambient light. So it's render pipeline. And here we're creating render pipeline. And then we need to pass ambient light. We can go, now everything's broken, that's quite alright, because we still haven't finished here. So we can create lights here, const ambient light is new ambient light. It needs device color, and then it tells that we can darken it a bit, let's say 0.5, and then paste it in. And we're going to have to call this update method that we had on a light. Okay, I have some errors. I'm going to check them, probably something in shade. So it says invalid command buffer, but I know, I forgot that often happens when refactoring. So we had ran the pipeline, but we never changed the shader type here. So I can get rid of this. It's material shader, it's not anymore unlit material shader, and now we have a shader error of var declaration. Something is wrong with our shader. Let's check it. So it says var declarations that are must provide an address space. That's weird. All right, let's see. Aha, I think this needs to be uniform, of course. Okay, cool. And there it is. So it's a bit darker now because of the light calculations. So that's easy part. Now regarding second part, which is this diffuse light. So we can do diffuse light quite easily, and I'm just going to draw it here because it's not that hard. So basically the idea is every surface, so let's say this surface needs to have normal, and if we have a normal, we can calculate light from that. And how? So basically our first type of light, which we're going to do this time, is directional light, and specific for direction light, it just has direction, right? So it's just some vector, it can be vector 1 0 0, it just has direction, and that's it. So basically with directional light, we take inverse of that directional light. Let's take a look at this, and let's call it directional. So we have this vector. We kind of reverse it when we're doing this math, and then take dot product of unit of vectors of these two, right? We take dot product, and then we get some value between -1 and 1. The thing is, here in this space, right above, it's going to be either 0 if vectors are like this, if they're orthogonal, and then it's going to be 1 if they're pointing in the same direction, and same is true for here, right? If they're below, they are actually, they can be -1, but we're just going to clamp value to be 0 to 1. So we're not going to deal with this, and we're going to do that in a shader. So that's it. And what's the normal vector? So basically every surface, if we take a look at this, well, basically our pedal or this cube, so the normal vector for the top part of the cube goes here, for the right goes here, for the bottom goes here, here, and then for the back it goes back, and then for the front it goes here. So basically it's just a vector that's kind of orthogonal, right, to the surface. And if we have a cube here, right, so for the right side it would be vector here, here, then top. You get the idea. So for this kind of vectors, we're going to need to modify shade a bit further. So where do we start? We need the normals and we need the light. So let's start with the normals. So the normals are going to be defined here, like a vertex attribute. And so we can just output normal. And that's it. So let's do first the normals. Let's make sure that they work, and for that we're going to need to go to our geometry, and then let's say that we can output normals as well. Okay, this is not working. Normals, it's a float array, and then we're going to build them. And for our cube, I made a bug here. So front is actually the minus, right? Because if we take a look, we're always looking towards positive z direction, so back should be positive z and the front should be minus. Okay, and then I'm just going to copy all of this, because then it's easier to think about it. And then we can do here normals. And what's the front normal? Well, it's vector 0, 0, minus 1, right? So I'm just going to copy that 3 times. Back is 0, 0, 1. Left is minus 0, minus 1, sorry, 0, 0. So what's the right? It's the positive. X, what's the top? It's 0, 1, 0. That's the normal. And if you're wondering how to find normals of a surface, well, you can take the cross product of 2 points of the surface. Okay, and with the normals thing is sometimes this, it can go up, it can go down, both are valid. So it depends on the winding order, how you do the cross product, but that's not the point of this video. So here we have normals. And usually if you're doing Blender or stuff like that, you're going to get normals from the Blender, probably. Okay, so we have geometry builder, normals, did I paste them in? No, I didn't, so I need to do that as well. To our cube, so we're not going to cover quad because we don't care about it right now. Cool, so let's see further. So if I go to our geometry buffers, so we need to create buffer for those normals. So I'm just going to say public read only normals buffer. And then we can copy these texture codes. So now be careful here. So we're modifying normals buffer. So we're updating here normals buffer, and here, wherever the text codes are, this needs to be normals, here as well, and then we're just going to call it normals buffer. I'm going to format it, and that's good enough. So now, in our render pipeline, here we need to pass it in, but we also need to push it to our layout. So normals buffer, this is alright, and here somewhere we were having these buffer layouts and we were pushing them. So we're going to do one more. This time it's 3. Here it needs to be float 32 times 3 because it's a vector of 3 points, and then shade the location, it's 3, and it works. Alright, so with that we can assume that I pasted in normals correctly. So we can do that directional light, and directional light is not that hard either. So here where ambient light is, we can just do directional light. We can copy ambient because we're lazy. We can just rename it directional. So one more vector, and that's direction, and that's a vector 3. And by default, we just want to go from top towards the bottom. So 0, minus 1, 0. We need to import it. Buffer. I'm going to assign the buffer size of 8 times size of float. And then we can just expand here as well. Why 8? Well, it's because I want to align those bytes to length of 16 or whatever it is called. Basically, you know, the SIMD operation, so SIMD optimization usually. So it's probably better for buffer if everything is aligned to 16 bytes. Okay, cool. We're almost there. We have our directional light. So we need to do it in shader, which is not too hard. So similar to here, I'm just going to shamelessly copy paste. We're going to have directional light. We're going to this is not going to be color. The location is 2, and then we can say direction. Okay, we have direction. So similar to here, it's a binding 1 though. So it's directional light. Directional light. simple enough. And then we can do here directional. Directional. Let me spell it. Slash diffuse. So this is our diffuse component for now. So we need to normalize that vector, and I mentioned that we need to use negative vector, right? Because, so what did I mention? So our light might come from here, but when we're doing the math, right, we need to reverse that light vector. Okay, we have light direction. So here, this is quite alright. The normals, we could normalize it here, but yeah, let's just normalize it here. So let's just say n is normalized in a normal, and then we're going to do n. So we need to take dot product, and this is what I mentioned, right, when I was explaining. So in case if we have some vectors that look like this, so the dot product of 2 is going to be less than 0. So in that case, we do max, right, and then with 0. So this is going to give us either this value or 0, whatever whichever the value is greater. So if our dot is minus dot, it's just going to become 0 because of this. Okay, and then color amount, and then we just do directional color times density, and this times this diffuse component. All right, that's it regarding this light. And then we need just to do the render pipeline part as well. So here it's going to be directional light and not ambient. Here it's rather directional light. So yeah, that's correct. Let's just see where we need to paste it in. Okay, it's something on here. Let's quickly fix that. Let's see, where do we need to fix it? So buffer layout, that's quite all right. So lights group layout. So we just have binding 1, visibility is in fragment, and then buffer. And then finally we need to paste it when we create a lights binding group, and that's exactly here. And this is a good suggestion. So binding 1, directional light buffer. And something is crashing. Let's ignore it for now. Let's just go to our main and try to create that directional light. And directional light, device, color is white, intensity is this, and then we can say that it goes in positive direction, but it's still crashing. So that must mean probably our shader hasn't compiled or something like that. Let's see the errors. Undefined buffer. That's quite interesting. Let's see, what did we do? So our directional light buffer is created. We're passing here. I'm going to call this though directional as well. Okay, this. So here I haven't pasted in actually. Right. So in our pedal, I forgot about it. So what did we need to pass? So in pedal, pass directional ambient light and then directional light, and then paste it as well to the render pipeline. If you get stuck, just check the GitHub code, and then we need to paste it in. And I would also probably need to update it. It kind of works, but it's not correct because I didn't update it yet. So let's do that, update. And now it gets interesting because now it doesn't work. So my math is not checking out somewhere. And let's actually check it real quick. What might be the issue? So let's just see the contents of our buffers. Okay, so we're kind of interested in directional light buffer, and this seems correct. So it's passed correctly into shader. So let's just check if our normals are alright. So our normals, and they seem quite alright as well. The normals are good. So it must mean I have done something wrong in shader. Directional intensity times diffuse. Let me check quickly. So if I change this direction, nothing. Interesting. So let's do it like this. Let's just output return. So we're interested in diffuse.red. Okay, that didn't work. Well, as it turns out, everything was correct except that our light goes from top, and I didn't want to do that. I actually wanted to do this. Well, this was kind of embarrassing for me because, well, yeah, I was debugging it quite a lot. So we can just check our directional light now. So basically, if it goes from the right to the left, actually if it goes to the right, so this side is lit, and if I reverse direction, it should be true for this side, and this one is not. Okay, that's correct. So we can just change it to 0 0 and then 1, and that's what we want to do. So basically our light is shining towards the positive Z, right? And since our camera is some 0 0 minus 20 looking towards 0 0 0, this side is kind of lit. Okay, that's cool. So finally, we're just going to pass it for ball as well, but we're not going to see anything with the ball, at least until we actually start moving it, but we can just do it regardless. Ambient, it's ambient light, and then directional light. So we can pass ambient and then directional. We can import everything. So we just need to do it here as well. So I'm going to do this, it works. Okay, well, that's it for this video. Hopefully you enjoyed it and didn't find it too hard. So lights are basically easy. So just to recap it. So basically we had ambient light, which was just a constant. I'm not going to even explain it. And then we had this idea of a normal vector, right? Which is kind of orthogonal to surface. We had this idea of normal vector, and then I did this idea of directional light, which we actually reverse in our shader. We do dot products of normalized vectors, right? They need to be normalized. That are the ones that might want to check out, and then you get this minus 1 to 1 value, but we actually clamp it so that we either take 0 or 1, as you can see in the shader. It's actually clamped via dot product, so via max, right? It's clamped. And why does this work out, you might ask? Well, because the dot product of two vectors, so let's say that we have normal vector and then we have this light vector, right? So if we take their length and then the cosine, sorry, not this, cosine of an angle between them, that's actually equal to dot product of two vectors. So in case you're wondering, I'm not going to go to mathematical proofs here, but that's what it is. So hopefully you enjoyed this video. If you liked it, please like, subscribe, and until next time.